Hi everyone, hope you're well. Yeah, I have to say it's been quite a journey to get here this evening. For some reason, don't know why, my internet has entirely gone down, but only for downloading things, but not uploading. I don't know. So put it this way: either I could be talking to absolutely no one, or you could be hearing me. I don't know because I can't see anything. I'm just working blind, but that doesn't matter. I'm going to carry on anyway. So, as you may have seen in the loading section, that today we're going to be using create.withcode.uk. And I've shown this before. This is one of my favourite Python editors, and it allows you to run Python straight in the browser. Nice and easy. And I thought, what can we make today? Well, let's make an alphabet translator. Well, what do I mean by that? Well, I mean a program that takes an input. That input is in our normal standard alphabet, Latin alphabet, A, B, C, D, and so on, and translates it into a different kind of alphabet. And there are good examples of different kinds of alphabets. You've got Morse code as an alphabet. You've got the International Phonetic alphabet. You've got all sorts. And, well, to do that, we're going to use a little bit of Python known as Python dictionaries. And all a Python dictionary does is it translates one thing to another thing. And, someone's asking on the Discord, are we starting? Yep. Yes, we are. So, the first thing we need to do is we need to give our dictionary a name. And once you've got createwithcode.uk loaded, let me stick that in chat for anyone who wants a nice easy link. Well, the first thing is we need to name our dictionary. I'm dull and boring and quite old. I'm just going to call it dictionary. And we need to say what it's going to be, so we're going to use an equals. Everything's going down and breaking. Oh well. And this is where we put our... Terribly sorry, my internet's gone down again. This is going to keep happening, so ignore me. I'm just trying to sort this out. Come on. What are you talking about? Server not found. Anyway, I can't see any chat you're sending, so I'm just going to carry on blind. Anyway, so we need to start filling out our dictionary. So to show Python that we're starting our dictionary, we're going to use an open curly bracket. And that means we've started our dictionary, and anything that we put after it is going to be included in it. And you can tell it's going to be included because as soon as I press enter, it automatically puts in a tab for me. It automatically indents what I'm going to write. And what am I going to write? Well, a dictionary is made up of one letter or word or phrase paired with what it translates to. So if I am making a program to translate, I don't know, Spanish to English or English to Spanish, I would have an English word on the left and a Spanish word on the right. And we're not going to do a translation of actual languages here. We're just going to use translation of alphabets. So let's look at the first letter. Let's do A. So I'm going to use speech mark, A, and another speech mark. That's the first part. That's what's going to be translated. And to show I'm moving on to the second part, I'm going to use a colon. and a space, and this is where I write the translation of it. So if, for example, we were doing the International Phonetic Alphabet, which is, oh gosh, my memory. Alpha, Bravo, Charlie, Delta, Echo, Foxtrot, Golf, Hotel, India, Juliet, Kilo, and so on and so on. Well, we can do that by, well, let's translate A. What goes with A? Well, that translates to alpha. And notice that I'm surrounding alpha also in the speech marks. And that's the first part of our translation. And if we wanted to carry on writing the second part, we could put a comma afterwards, and on the next line we could do B. And if we're going to carry on doing our phonetic alphabet, we could do Bravo, followed by a comma, and so on and so on and so on, and making sure that we're surrounding each letter and each translation with a speech mark. Now, I could go on, but let me just close this dictionary off for now. And to close it, I'm going to use a close curly bracket. And, well, this is an excellent opportunity if you want to create your own alphabet. So I could have it so that A translates to, I don't know, fish. B translates to cat, and so on and so on and so on. It doesn't matter. But the important thing to know about dictionaries is the first part, the bit before the colon, is called the key, and the bit after the colon is called the value. So you have key, value, pairs, as they are known. And if you don't want to write out a full dictionary, luckily for you, I've written a couple already. And if you go ahead and head to this link here, github.com/technocampsjack/alphabet translator. I will try and get that posted into chat, but I have a suspicion that my internet's not going to let me. It's loading. Oh, we'll see. The link for those on Discord is github.com/technocampsjack/alphabet translator. And when you go to that link, is it going to load for me? Oh, well, this is frustrating. Oh, it's loaded. That's weird. Surprise. Yeah, when it's loaded, you should see a page like this, and you should see a little file called alphabets.py. And if you click on that, you can see that I've already written out some dictionaries for you. So this is dictionary 1. I've just used animal names because why not? You can do whatever you like. It's your alphabet. I've got dictionary 2, that's the phonetic alphabet. And finally, I've got dictionary 3, which I've left completely blank, so it's easy to fill in for yourself. So let's take the animals. I'm just going to copy and paste that. And rather than write out the whole thing, I'm going to cheat, basically. Feel free to write your own, or you can copy one of mine. But there's a couple of things to take note of. If you look down here at the bottom, you'll see that I've got some extra things at the end. See, I've got a blank space. So if someone types space, it'll be translated into snake. And I've got a full stop, and that will be translated into rat. Basically, anything that you type in that is not in this dictionary will cause an error. So either you have to be careful what the user types in, or you have to write in lots of different options into your dictionary. You could even write full words if you wanted to. But now we've got that underway, we might as well start translating it. We need a small little function that will take what the user writes in and translate it for us. And we're going to use a function called Encode. So in Python, we declare a function by typing in def. And it stands for define. And I'm going to define a function, and I'm going to call this one Encode, because it's encoding what the user's typing in into whatever we've created, whatever language we've created. And after typing encode, I'm going to make sure to include an open bracket and a close bracket. Python needs this to know what a function is. And finally, a colon at the end. Without the colon, it won't work. And as soon as I press enter, it jumps me onto the next line, so it's nice and easy to put things in ready. I'll just pause on that so everyone can get a encode function. Pause over. Let's start the next bit. Well, we need to grab an answer from the user. And to grab it from the user, we need to store it. So let's create a variable. Let's call that variable answer. And I need it to be equal to what the user types in. So I say answer equals input. But it's not really a great program if we don't have someone actually, putting something sensible in. Who's going to know what to type in if they're not asked what they're going to type in? So I'm going to open a bracket after input, and I'm going to open a speech mark, and I'm going to prompt the user for what to type something in. So, what would you like to translate? And of course, I'm going to close it with a speech mark, close it with a bracket. So let's just test things out. Let's wait on that. Actually, let's just move on. So I need a way of storing what my translation is, and we're going to store that in a variable called output. And we need to initialize that variable, and that means we need to make sure that variable is empty. So we can say output equals, how do we represent emptiness? How do you represent a sentence of 0 length? Well, we can do that just by putting one speech mark and another speech mark directly next to each other. That's a sentence, that's a string of absolutely no characters whatsoever. And what that's done is it's given us, it's made output be completely blank. And we can do whatever we want with output now. So let's start adding stuff into output. And, well, how's this going to work? Well, what we need to do is we need to take the user's input, and we need to scan the user's input line by line, and then take each letter of the input and translate it into something else. And so if we're going to be scanning things line by line, well, of course, the best way to do that is with a for loop. So I'm going to start by typing for. Then we need a variable, I, and it needs to be in range. Open bracket, close bracket. And what this is going to do is it's going to scan through the user's input. So when does it need to stop scanning? When's the limit of scanning? Well, we need to take a look at the answer and see when the answer stops. When's the end of the answer? And for that, we need to find out the length of it. And to find out the length of any value in Python, we use a little function called len. Of course, it's hard to say. Len is short for length. So we run to the length of the answer. So let me cover that. We have a for. We have a variable I. I will start at 0 and it'll count up until it reaches the limit of how long the answer is. Let's close that off. Notice I'm closing this for loop off with a semicolon, just to make sure. Right, what else do we need? Well, let's press enter after our for loop, and that will take us on to the next line. And also, it'll indent us a little so we know that we're working in the right place. And we need to grab a single solitary letter from the answer. And to grab it, I need to store it. So let's make a variable called single letter, because it's just going to be one letter of the answer. Say the user types in, I don't know, umbrellas. We just want to grab the U, then we want to grab the M, then we need to grab the B, then we need to grab the R, then the E, the L, the L, the A, and the S. So single letter equals. And how do we grab each letter of the answer? Well, for those who are a bit more comfortable with programming, you can see that an answer is going to be a string, while in Python, you can treat strings like they're arrays. So you can access each part of a string as if it were each part of an array. So in simple terms, what you do is you write answer, and then after answer you put an open square bracket, and inside that open square bracket you put where you're going to have the position of the letter you're looking for. Which letter? Where in the string are you looking for the letter? And we're going to use I for that, so we're looking for I. And then we can close the square bracket. And that's all we need for now. We'll have to come back to this line, so make a note of which line it's on. So what this is doing is it grabs each letter from the answer in stages. Now we need to look in our dictionary and see what letter that letter should be translated into. Excuse me a moment. I'm just trying to log in to something, and the Google Captures come up. I'm not a robot, honest. I don't know how many times I need to tell you I'm not a robot. Come on. Trust the internet. It works fine all day. As soon as it comes to streaming, it goes down. Terrible. I'm going to have words with my ISP. Anyway, as I was saying, we need to look up in the dictionary, and so we can put that inside our output. So we're going to be accessing our output, so I'm going to write output. And I need to change output. I don't want to overwrite it, I want to add to it. So I'm going to say output equals output. That might seem pointless, but we're going to say output equals output plus whatever we're searching up. And we're searching inside the dictionary, so we need to look at the top and see what we called our dictionary. This one's called dictionary 1, so I need to call it dictionary 1. I'm going to say output plus dictionary 1, but not the entirety of the dictionary. I just want to look up the single letter. So open square bracket. This is where we use our single letter. Close square bracket. Okay. That's a problem though. If we're translating things, then it's just going to sort of mush the words together. We won't be able to see. It's like letters. Letters don't have a space between them. We need to find a way of separating them out. So what we're going to use is we're going to create what is known as a delimiter. And what this does is it shows where one letter starts and the other letter ends. So we're going to add, as in plus symbol, onto the end of our output. And we need to choose a delimiter, and a delimiter that's not very common in written speech. So let's have, okay, well, I'm going to need it surrounded by speech marks anyway. And inside those speech marks, let's choose a symbol to be our delimiter. What about backslash? Yeah, backslash works. Righto. What should we do next? Well, we're done with our for loop. We're going through everything already. Let's kill off our for loop. So after pressing enter, I need to go back to needs to be in the same column as the start of this for. So I'm going to press backspace, backspace to get there. And this is where we can actually show our output. So print. And what are we printing? Well, we're printing the output. Right. Press enter a couple more times. Backspace back to the beginning. We're all done. We just need to call our encode routine. And to call it, I can literally write at the very bottom of the page, encode, open bracket, close bracket. And we'll see if that works. Let's click the play button, see what we get. Ooh, that's appeared over there. What would you like to translate? Oh, you can see I've tested a couple of things. Let's translate, let's be boring. Let's translate hello. Actually, that's not going to work because we don't have any capital letters. Let's try hello in lowercase. Oh, my entire page is going to resize. There we are. Click OK. Okay, so hello translates to emu, dog, hamster, hamster, goat. And we can kind of tell that works because we've got two hamsters where the two L's should be. And if we were using a different alphabet, you get a different result. So, for example, let's change emu, which was H. Let's change that to, I don't know, can't think of an animal now. That's embarrassing. Hippo. Okay, let's see if this works. Let's try hello again in lowercase. Hippo, dog, hamster, hamster, goat. Excellent. We've got an encoding routine. But what about decoding? What happens if we want to translate backwards? Or even better, what happens if we type in hello with a capital H? Let's see what happens when we click OK. Oh, we get an error. And that's because our dictionary doesn't contain a capital H. So we could put in a capital H into our dictionary and have it translated. To do that, we just tack it onto the end, like so. But that's going to be a problem because we'd have to include a capital version of every letter in there. So let's make it better. Let's actually have it so that our answers are automatically brought down to lowercase. So remember back to when I told you to remember which line that we'd be editing in the future? Well, it's this one. It's single letter equals answer I. Now, answer's going to come in as the user's written it. So whatever the user writes, that's what answer will be. If we force that answer to lowercase, to smaller letters, then we're not going to have to write more things into our dictionary. So after answer I, we can put dot, lower, open bracket, close bracket. And that forces it down to lowercase, which is, it's a nice, easy, bit of a hacky way to do things, but it works. Right, let's work on our decode routine. So before the end of the page, but after encode, let's make a decode one. Let's call it, well, it's a function, so we need to use def. And we're calling it decode. And like all functions, it needs an open bracket and close bracket and a semicolon afterwards. Right, what can we do with this? Well, you might think this is very similar to the encode routine, the encode function, but not quite. There's a problem, you see. The dictionary is not really meant to be used the wrong way round. You see, here we're allowed to grab the value by giving it a key. But with dictionaries, you're not really allowed to grab a key given a value. So we have to do a little bit of tricky. We have to do a linear search through the dictionary to find our key. So the first part is exactly the same. Let's do it exactly as is. Answer equals input. You can copy and paste. I'm going to write it out just because, I don't know, my fingers need the exercise. So, what would you like to translate? And on the next line, we need an output. And it needs to be set to nothing. And this is where things change up. This is where we make it more interesting. So, you know how I was saying that the answer is treated like an array? Well, we can actually split that array up. Nice and easy. So we need to store our split up array. So let's make a new array called code words. And we can set the code words equal to, we need to split up the answer. How do we do that? Let's use a function. That function's name is str, which stands for string, dot split, because we're splitting it up. First of all, we need to say, what are we splitting up? Well, we're going to be splitting up answer. So let's split up answer. And we need to say how it's splitting it up. Now, if you leave the split function alone, all it will do is change. It'll split the array up by spaces. So every time there's a space, it'll create a new word, a new element of an array. We don't want that. We used this delimiter here, this slash. So we need to use the slash delimiter here as well. So open speech mark, backslash, close speech mark, close bracket. And that is the decode. That's the splitting up into code words part. Let's make sure it's working. Let's just print the code words for now. Let's just print code words. I'm going to test this function, and to test it, well, let's just test it in a hacky way. Let's just change encode at the bottom to decode. So it won't call encode, it'll call decode. Okay, what would I like to translate? Let's translate fish, donkey, duck. And if I get my calculations correct, well, nothing should happen. It should just split it up nicely into 3 elements in an array. We haven't done any translation now. Let's get on to the translation. So underneath where you've printed code words, let me just add some space so it's easier to see. This is where we can actually start searching through the dictionary. Now, to search through the dictionary, we have to search through our code words. So we're going to use a for each loop. So we start by typing for. Now the each part, we don't actually type that, but we always talk about the each part because this is known as a for each loop. It's basically saying for each word inside code words, do something. So don't forget the colon at the end. For each word in code words, what do we do? Well, we take that word and we see if it's in the dictionary. And if it is in the dictionary, we return what key it is. So say we're searching for cat, it'll say, okay, for each word in here, is cat next to, is cat fish? No. Is cat donkey? No. Is cat duck? No. Is cat cat? Yes. Well, then we're going to translate that into D. So in our for loop, we need another for loop that's going to search both the key and the value. So for each key and each value, I'm showing it's doing both by putting a comma in between. For each key value inside or in the dictionary, remember that mine is called dictionary 1. Yours might be called something else. For each key value in dictionary 1, what are we going to do? Well, we need to turn the dictionary into a list of items first. So after that, we're going to type in dot items. I'm going to open bracket and close bracket. And because this is the end of our for loop, of course, we're going to need a colon. Right, what are we doing underneath? Well, this is where we see if the value is equal to the word. And how do we do that? Well, we do it exactly as I said, just translate it into Python. If value equals word. It needs to be equals because when it comes to comparing things, always use equals. When it comes to setting things, 1 equals. If the value is equal to the word we're looking for, then we can add the key to our output. So output equals output plus key. And, well, that's it for our decode function. That's all we need. Let's print it out, though. So I'm going to press Enter once, and I'm going to backspace until I'm in line with this 4. And we're going to print output. Okay. Let me leave it up there for a second. So just to double check for our decode, we grab the answer from the user. We split it up into an array. So each word is in its separate little box. We print what we've split up. And for each word in the array, we need to search the dictionary to find that word. And if that word is found, we return the key. Let's see if this works. What would you like to translate? Let's do fish, donkey, duck again. That should be ABC. Let's click OK. And it translates it back to ABC. Okay, let's test whether the encode and the decode work together. So at the bottom, I'm going to put encode above decode. So it's going to call encode and take us up to encode. It's going to run through encode. And once it's finished encode, it's going to go back down to the bottom and it's going to run through decode. So it'll do encode first, followed by decode. What should I translate? Hello, world. Or at least I would if I could spell world. There we are. Boring, but it's traditional. Hello, world. And click OK. So hello, world should translate to hippo, dog, hamster, hamster, goat, snake, eagle, goat, oyster, hamster, cat. Let's see if it runs correctly backwards. I'm just going to copy and paste that because I'm lazy. Let's decode it. And it translates exactly back to hello, world. And that's it. Let's neaten this up a bit, though. It's a little bit of a messy setup. Now, we've got encode and decode at the bottom, but it's not really a program. It's more of a sort of a hacky testing mess. Let's make it into a bit more of a rounded software package. So with Python, usually when we're wanting to do things first and we're using functions, i.e. we're using defs, when we want things to happen first, we usually stick them at the bottom. It's a bit hard to explain, but we'll just do that for today, and don't worry if it's confusing. Now, at the bottom, we're going to put our first part of our program, which is going to ask, hello, user, what do you want to do? Do you want to, I don't know, encode something, or do you want to decode something? And so that's what we're going to ask. And because we're asking the user, time to use a variable to store their answer. What should I call this variable? Let's call this variable begin. Let's say begin equals, we grab input from the user, so begin equals input. Now with the input function, anything we put inside speech marks in the brackets after input is what gets asked to the user. So what would you like to do? Encode or decode? Type E or D. So if the user types E, then take them to the encode function. If the user types D, take them to the decode function. That's all we're doing. So we'll need something to tell what begin is, and of course that's going to be an if statement. So if begin equals, because we're comparing begin with another letter, if begin equals E, then what should we do? We should say, well, we're going to take them to the encode function. So encode, open bracket, close bracket. So when the user types E and presses enter, they'll be taken to the encode, and they'll be typing, they'll be converting English into our new alphabet. And then we've got elif. Elif, let's have, so elif, which stands for else if begin is equal to D, then we should go to the decode function. Let me leave that up there for a second. That should be enough. Let's give that a go. Let's click play. Let me maximize this. What would you like to do? Encode or decode? Type E or D. Let's do encoding first. So I'm going to type E. What would you like to translate? Let's do, this is how I encode. And I click OK. This is how I encode translates to octopus, hippo, cow, crab, snake, hippo, goat, eagle, snake, cow, snake, dog, sheep, duck, goat, cat, dog. Whew. There we are. That's our encoding. Let's try our decoding. I'm going to click play again. What would you like to do? Let's do decode. What would I like to translate? Let's do crab. Let's do eagle. Let's do fish. Let's do sheep. Let's do crab. Let's do dog. Let's do fish again. I hope I've got this right. It's not going to spell something rude. Swansea. There we are. Crab, eagle, fish, sheep, crab, dog, fish. And that equals Swansea. So there we are. Now, we can easily change out this dictionary to include whatever we want. We can add new things on the end. So, for example, what happens if someone writes a question mark or an exclamation mark? We can add those in. So if you see a question mark, translate that to, I don't know, have I got horse? Yeah, I've got horse. New animal. Aardvark. There we are. I've added one onto the end. But the most use you can get out of this is actually, if, for example, you wanted to create a Morse code translating app. Let's do, let me find the Morse code alphabet first, mostly because I haven't memorized it. There we are. Okay, so in Morse code, A is a dot followed by a dash. B is dash dot dot dot. C is dash dot dash dot. D is dash dot dot. This could take a while. E is just a dot on its own, and that's an interesting reason. Part of the reason that Morse code is designed in this way is it's all based on the frequency of letters. And as in English, E is the most frequent letter. It also has the shortest Morse code equivalent to type. It's just a single dot. So if you think about it, if you stack up all the different E's that a Morse code telegram operator would have to use, if it were something ridiculously long, like dot, 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 dash, dot, dot, then obviously E's are going to take a lot longer. Now I've said that, I'm on to J, which is an awkward one. That's dot, dash, dash. It's dash, dot, dash. Dot, where am I? Up to L. Dash, dot, dot. You get the picture. It's easy to find the list of Morse code online. Let's run this, and let's just try something simple. Let's do an encoding. Let's say we wanted to translate, I don't know, cab. Say you're getting on the telegram to ask for a cab. Let's click OK. And if you were operating a telegram, you'd have to do dash dot dash dot dot dash dash dot dot dot. And there we are. It's a translation for us. And each delimiter, each backspace we've got, shows you a pause in the operation. Anyway, that's pretty much it from me. It's a bit shorter one today. I will be sticking up on the Technocamp's website a full Morse code alphabet for you. You can find that on the GitHub. In the meantime, relax and listen to some music whilst I help those out and a little bit stuck. Anyway, I hope you have a lovely evening, and goodbye.